Hello everyone, welcome to the SUSE QE Tools Workshop. Today's topic will be about the Opengl OpenSUSE org infrastructure. So, now I asked today in the team chat channel who wants to present that. So I wonder who would like to give it a go and talk about the O3 infrastructure. I'm the fallback, obviously. Okay, so I will do a start and then you can jump in. Let me for that share the wiki page of the Opengl project. So on progress OpenSUSE org projects Opengl wiki, what you will be able to find there is a section about the infrastructure setup for both O3 and OSD. And it starts with a section about O3. So we as a team, SUSE QE Tools, we maintain both these infrastructures. They are both a bit different. They have their differences. And actually, we're also trying to make tap into the benefits of the differences, and then I will come to that. So first, O3 consists of a virtual machine that is running the web UI itself, and then there are physical worker machines. The VM, there's actually an O missing, I can correct immediately. The VM that we use has a NetApp-backed storage on rotating disk, so it's less performant than the SSD which we have on OSD, but also more price efficient. And currently we have a total of 10 terabyte of data, and the biggest amount of data is used for OpenQA assets like ISO images, QK images and such, as well as the actual test results. And commonly we try to, when we run into some limit, we monitor that. When we run into some limit, then we see if we need to adjust the settings or extend the space where possible and such. The complete O3 infrastructure is automatically deployed on a daily basis, which includes both the web UI host as well as the workers. And there's a difference in how that is done. So for the O3 web UI host, that is done with a periodic nightly job that updates automatically the VM. And the Opengl workers, they are, at least all except for the machine Power 8, they apply a daily automatic update as transactional servers. The only difference then is that Power 8 is non-transactional with a weekly update every Sunday, which in the last 2 years didn't make any problem. So this is also a slight difference, but it's actually also, can be beneficial because this is kind of the experimental host which we can use sometimes to to check for differences, because we know that maybe Power 8 has not yet been automatically updated with something. And the machines are all manually maintained. So some years ago, Salt was used before that switch to transactional machines was used, because at that time the support within Salt for transactional systems wasn't either not existent or not reliable enough. So it was selected to, just to continue with the state of what we have and maintain manually, which actually turns out to be really low effort and rather low risk. This is paired with the fact that, with the transactional machines, there is a lower likelihood of random dude joining and doing stuff that cannot be followed up with afterwards, or even it's not easy to make it efficient, make it effective, make effective changes when one doesn't know about the transactional servers, which is a good thing. Just yesterday we had a problem regarding multi-machine tests and some dboss call, which was introduced by a change in auth-audience, and that is a part of auth-audience where we knew already that this is not easily automatically covered with tests. So the likelihood of something breaking in that area was high, and actually it happened that some unforeseen problem creeped in which affected actually both O3 and OSD, and we had a nice opportunity to to try out how that rollback worked. So maybe we can also talk about that later. But we also mention, in case we do want to execute commands on any workers, what we do is basically we have a for loop with a static list of the hosts, and then what we do is we log in and then we execute a command. So this is one example where we say maybe we want to do an out of order explicit manual update of all the hosts. So what we do is we call transactional update dub, and if that doesn't work because we do have one host which doesn't use transactional update, then we call zipper instead, and afterwards, like if this worked, the subshell, one of these two worked, then we reboot. And that's commonly like we trigger that, and some minutes later all the machines are upgraded and rebooted automatically in a clean state and perfectly running again. And in most cases nobody ever noticed, because in the case that jobs do get aborted, then they will all be automatically cloned, and the web UI itself will also just pick up where it was. So that was not a problem at all. Any questions so far? Any additional notes that you want to add? Then I would go over the rollback of the updates, provide a bit more details, and then afterwards I can also show how that works in practice. So for the rollback of updates, so this is also very similar to what we have here in before. In case of the transactional hosts, we do have power 8 here in the list, but actually it would just be ignored on that host. What we would do is we call transactional update rollback last, reboot, boom, done, all ready, and rolled back to the last state. So in case if there is any problem and we realize a problem, we just call that command, and then for that day everything is perfectly fine. The only thing that we need to ensure is that, so that the next nightly update would not introduce the same problem again, or another problem, is that we fix that problem within the day. So what we can do is we either revert, in the meantime we revert the change, like in GitHub for auth-audience or Opengl. And by reverting, we automatically have a package generated from the merged code, and that package will be available as the update for the next nightly upgrade. Or in other cases, or in most cases, because it's mostly smaller issues which are in really known areas, because we do a nightly upgrade every day, so we know exactly it must be the change from the last day. So also the diff is very small and then easy to identify what went wrong, and a fix can commonly be created and be published and merged so that we have a new updated fixed package available within the same day. Yeah. So this is for the workers. For the central web UI host, that can be rolled back by using all the variants of package that receive maintenance updates. So if it's an update that was received as a maintenance update for Leap, then we can just use zipper to install the old update, which is available within the maintenance repos. Or in case it's one of the packages that we maintain, meaning it doesn't come in as a maintenance update, but as a new package from development repos, then we do zipper in old package and install it from the local cache. So we just have configured the machines to install from a local cache. And actually, this is an entry which I just added yesterday. We do have by now an OpenQA rollback script within main OpenQA, which we use for OSD, so internally. And I just provided it here as a reference that this would work the same, where we do execute semi-automatic rollback for OpenQA SUSE QE. We use the same. We rely on the zipper packages in cache, and then we install the old package.
One question on that. Don't we have some long-term plans to, for instance, make this actively used elsewhere as well, and not just internally?
You mean because we have a rollback script in the main repository?
Well, so for some of the infrastructure stuff, at least we already have plans to share the code. Like we want to share Salt stuff, right? So I'm thinking rollback. Is that something that's going to be shared as well?
Yeah, exactly. So I mean, how did we come up with that approach? So first we had just code in the internal GitLab CI YAML file. And then, of course, it's becoming a bit tricky to maintain a shell script that is executed over Salt within an SSH session, within an encoded shell string that you put into a shell section of a YAML script with all the quoting and multiple levels. So what we said, like, okay, it's easier to extract the script. Where to put the script? Well, we could have put it within the same internal GitLab repo, but then we decided to say, like, well, you know, this could be useful for some other purposes, so let's just put it into the main repository. And then the outlook is to say, when that is working fine, and maybe we need to fix one or two things, then we can also include that in some, let's say, more published and more supported way, and mention that in the documentation. And this is the reason why I also like that actually the O3 infrastructure differs from OSD. So within OSD we use Salt to maintain the infrastructure, where we actually also have the plan to publish the Salt repository. The original plan was to use the same Salt repository again to manage the O3 infrastructure. But honestly, I'm not so sure anymore if we actually want to do that. Maybe it's nice to keep it different and still see where we can extract the common parts that are beneficial to the multiple different ways that an infrastructure can be maintained. So this OpenQA rollback script is just one way how it could be done, but actually the rollback script should be usable within a Salt maintained infrastructure as well as in an infrastructure where we don't use Salt, but you know, something different. Now I can demo a bit. So I will switch off the browser and I will share SSH terminal like this. Can you see that?
Yes.
Okay. So I'm logged in as my user on Ariel, and Ariel is the internal name for the O3 Web UI host. Oops, I thought that would be there. Now, how's it called? exist. Anyway, so what does it say here? Yeah, it says Arial, and if we take a look here, then we can see a bit more internals. So O3 runs within a dedicated network. This is why we also connect to the individual workers in this dedicated network, and some other hosts we try to redirect over different ways how to reach it then. Now from here, what we see is the storage layout. So here, for example, you see we have currently 5 TB assigned for /space, which we use for results, and then there's /assets. Assets is currently only assigned 3 TB out of the available 5 TB. So there's still something left in the volume group. This is managed by LVM, so we can freely assign that to either of the two. And what else? Well, let's use something fancy. So here we can see that the O3 Web UI host doesn't have that much memory. It does have multiple cores, 10 cores, so this is not like a multiple of 2, because it's a VM and that can be freely changed and assigned from the hypervisor host. We have the Postgres database, which is used for OpenQA. We run the OpenQA Web UI here, as well as multiple scripts. So for example, it is a Git repo update for the test repository and Needles is running here, as well as the job post hooks. They are all executed here on the Web UI. There's also DNS mask running, so that host is a DHCP server for the worker hosts in that dedicated network. How to do changes? As I said, it's maintained manually, and there is the OpenQA ini and the database ini, which we can use from here. And then that's the command, more or less, which I showed in the wiki page. I have, as a user, I have put in my SSH key for the root user of each specific worker host. And then we can connect to each host. Here I'm just calling uptime, and as you can see, for example, in the numbers, most of the machines are up since today, like the European early morning or Chinese midday, because this is when the automatic update happens, except for that which is Power 8, which was out of order updated yesterday and normally is done on the weekend. Yeah, if you're interested in the network interfaces, there we go. So we see that there are multiple network interfaces, and all of them are in an internal network subnet. So that machine is not directly accessible from the outside. How can you access SSH? That goes over a proxy. How can you access the Web UI? That also goes over a proxy. That also means that within that network, the workers connect to the Web UI host over HTTP. They don't do that using SSL. They do use that using, so they don't use HTTPS. They use HTTP, because the SSL is a layer that is added on top by the web proxy that proxies that whole infrastructure. So this is important to know if we take a look, for example. So let's log in to one worker, And if we take a look here in the workers ini, okay, that's not enough. So then we see that the worker host name is set to the internal name, and also here over in the host you see that this is nothing external, but it's using HTTP Opengl 1-OpenSUSE to access the web UI host. Any questions, comments, or addendums?
I have one.
Yep.
When you do some changes on OpenQA, I remember that it wasn't automatically. You have to go. It doesn't take the changes. You have to do another pull request to make changes on the config files, right? Where was that? What if you want to make permanent changes in the config?
If you want to make changes, then you would need to log into the machines and apply the changes in the local files. There is currently no repository that is holding the configuration files, like the worker config. So this file, which you can see here, is local to that worker.
But doesn't take. It's not permanent, right? If you do some minor change on the VM, in the next reboot, it's gonna lost the.
The changes that you apply to well first. So as a reminder, the most of the workers are transactional systems, which we can see here. If you take a look on the mount point for root, here you see that the root file system is read-only, which means that even as a root user, I can not change files within the root file system directly, with the exception of /etc, because that is an overlay directory, which you can see here. So this is just the normal installation that you get if you use the awesome transactional server preset from OpenSUSE. That means that changes to etc, like within here, they are permanent. They are persistent. Only if I install a new package or something like this, then, well, first with zipper I can't call zipper in my package. I can't do zipper dub. What I would have to do is I would need to use transactional update package install, and that is applied into a new snapshot, which only gets activated on reboot. So So the common approach to say I want to install a package or I want to update a package, which is production persistent, you would call transactional update package install and reboot.
And is it the same for OSD?
No.
No. Okay.
So for OSD we don't use any transactional systems. What we do use is normal non-transactional systems which do have a read-write file system, and the config files are maintained in Salt. So you would need to apply the changes to Salt. Maybe you also had another issue in mind, which was that if one applies changes to the workers config, that doesn't affect running worker instances. And we don't have a CI pipeline that automatically restarts all workers on any changes in the config file. However, we have found something better for that, which is that we have the automatically restarting workers. So let's see, list units. So if I list OpenQA related units, then we can see here that the actual services that are running are the OpenQA Worker auto restart services. And what they do is they automatically restart as soon as a job is done, and when that happens, it also reloads the workers ini. That means, and this is the same for O3 as for OSD, that means if you change the workers ini, the next job will have the updated workers ini, including updated worker class and such.
Cool.
So, what else? What is described on the wiki as well is, in case you want to interactively work with the QEMU system under tests within the OpenQA OpenSUSE org infrastructure, same as for any other system, you need direct access to the worker, because the workers here are also in a dedicated network. I can also show you the network config for a worker. You see all the top devices for a multi-machine configured system. And then you see a bridge, and then you see the Ethernet adapter. That this one also has a private IPv4 address, which means that this, of course, is also not accessible from the public internet, but is also not accessible from SUSE internal network directly. In any case, you need to go over proxy, which in that case would be O3. That's described on the wiki page as well. Now, what else? Let me check. I wasn't sure if we have a certain prepare service which reformats the file systems on boot up. Maybe not. Anyway, it doesn't matter. Right, other questions? Then I'm looking up the motivation for the topic that we're discussing today. I had, after there was a question about the differences in O3 versus OSD. Yeah, maybe one I can show some more things so that when you experienced with OSD, then you know where the differences are and where the things are just the same. So also I'm sharing a bit more internals. So I'm back to the web UI, but what we can do is for each machine we can show the workers ini. Just to give some rough idea. Of course, it's a bit too much text to completely read, but you can get the idea. So I'm scrolling up a bit, and what you can see is that in most cases the machines are configured for just standard QEMU. So for example, here we have QEMU x86-64, which applies to the same. Just in some cases, we only have a limited amount which are reserved for multi-machine tests. And then there's OpenQA Worker 4, which has nothing special at all. So there's only these two instances configured special. All the others run standard QEMU. On OpenQA Worker 7, there's even no specific instance at all, so it's just using the standard. Then we have Power 8, which is actually Power VM 8 machine which is also running, which is capable of running QEMU, and so it's not using the Power VM backend, but the KVM on SUSE backend on a Power 8 machine. Then there's Rebel. Rebel is the machine that is used for the S390X testing. So here we have special instances configured which connect to the reserved ZVM instances. We have Linux 144, 145, 146, and 147. So there are 4 ZVM OpenQA worker instances configured. Questions for the worker layout, different worker classes maybe?
I have one, but I'm not sure if it's related directly.
Try it. I can delegate you to later.
From the wiki, it says for ARC64 you need extra configuration. You need to set up huge pages support. I don't know what is the huge pages, if you want to say something about the ARC.
Okay, right. So let's take a look at that one. So again, as a reminder, we take a look at here, and then we see that it's configured for QEMU on all the instances. If we take a look at the kernel command line, then here you see how it's configured. So for performance reason, there are some security implications or some security measures explicitly disabled, and then here it shows how huge pages is configured, which then allows to run QEMU in the way. Actually, if we wouldn't have that, if we would lose that kernel perimeter, then actually you start an OpenQA test.
Can you move the line on the top?
Okay, sorry. Right. So here, this is the kernel command line, and this is where we see how we have huge pages configured. If you wouldn't have that, and if you start any OpenQA job, then it will incomplete, and the QEMU feedback would tell you what is missing. So what else? Yeah, the machines, the physical machines are maintained by SUSE IT. And the same as for other machines, we do have Ipmi Control over these machines, and this is then again something which is not within the same network. So within the SUSE network, any person access to the SUSE engineering network would be able to control the machines, for example, to take a look on the serial console in case of problems to boot up, as well as when you need to force a reboot, power it off, power it on, and such. Now then, the last thing that I would like to show you is the structure in valib OpenQA. So here in valib OpenQA we have standard directories. There's also a bit more. For example, there's an SQL dumps, which is a backup directory where we store database dumps from the database from every day, and that is also synced to another host. So in case that host would die here, which is unlikely because it's a VM running on redundant storage arrays, then we could recover the data in the database dumps. the factory directory, there we see the default HDD ISO other repo and temp, but there's also snapshot changes. As a Tumbleweed user, you likely know the mailing list post on OpenSUSE Factory telling about the new Tumbleweed snapshot and the snapshot changes. And that is actually coming from this directory. So here we have the changelog for every build of Tumbleweed. And then from that, a changelog diff is can be computed. The same is, I think the same also exists for Leap. I just don't know now where that is. And then we have the share directory with the tests. And within tests, then you see that we have the OpenSUSE directory, which is a git checkout of OS Odin's distri OpenSUSE. Then we have symlinks pointing to that with, for example, Cubic, MicroOS, as well as Windows. So also the Windows tests that are used, which is basically installation of Windows, having that in a QCore image, and then installing OpenSUSE on top in parallel to check dual boot. That's running from the same test repositories. But we also have two repositories which are not the same test repository, which is OBS and OpenQA. OpenQA, that's coming from OS Odin's distri OpenQA, and OBS is coming from OS Odin's distri OBS. So for you that don't know that yet, OBS, the OBS appliance, is also tested with OpenQA. It's a very simple and limited test coverage, but also, just doing what OpenQA can do in the best way for OBS, which is boot a system and then ensuring that the appliance is ready to be used by the user. So that's also a separate Git repository. I'm mentioning that explicitly because I know that many people always work with one single test distribution. So sometimes you might assume that it's actually the only one when that is not the case, because of course OpenQA can run with multiple test repositories. Any further questions?
Oli, how is the backup of O3 happening? The backup of the medium types, of the definitions of the job groups, etc.
Yeah, so the median types and job group settings, they are all included in the database. So what is then done is that a database dump is created on a nightly basis. That means also whenever we do a nightly update, we do have a backup before that. And that backup is on the local file system, which I showed you in the path SQL dumps. And this directory is also synced to an external source in case the complete file system would get corrupted or the VM would be lost. There's currently no recurring backup of test results or assets like QCore images or ISO files, which is something that we have plan with a lower priority because of the already redundant storage setup that we have here.
That makes sense. Thanks.
Right. So Chris, Jane, Nick, did I forget anything? Marius, did I forget anything to mention?
I think you covered the most important parts.
Maybe you can share experience, like how much work is it to maintain that? Do we see a risk with that?
It's definitely different. O3, but honestly, O3 is really not that much of maintenance, as not so many tests hammer it in my experience. But yeah, it's absolutely feasible, and especially with the transactional updates, once you get used to them, yeah, it's quite handy.
Cool, thanks. Other experiences? Nope. Okay. Unless there are further questions, then we can call this topic done for today. Thank you all for attending, and see you next time for the topic Opengl tests written in Python. Bye.